I will make you host.
Awesome. Hello, everyone. Thanks for joining us this morning or afternoon, depending on where you are. Today, we're going to be talking about RAG. This is one we have been asked for a few times because we've given some talks on it. So I'm excited to be able to share some of this content with you. Okay, so here's all it takes. We're doing RAG all wrong, and here's how we can do it so much better. So a little bit about me. I'm the founder and CEO of FeatureForm. My expertise is in recommender systems. I've been working with embeddings, vector databases, etc., professionally for since like 2018. So a lot of the stuff that we've been seeing in RAG are things that NLP practitioners and recommender system practitioners have been working with for a while. And for that reason, we've kind of are relearning, or a lot of people are relearning some of the hard lessons that we learned in those other adjacent fields before. So let's start with like a quick, kind of like almost like an intro to RAG. I know this will be a little bit of a review for a lot of you, but I think it will help set the stage well. So when we first started working with LMs, most of us went on ChatGPT for the first time. We asked a question, wrote some stuff, and we got responses. And what we learned very quickly was that it's really powerful. It's amazingly good at what it does. And so this is the idea of like a zero shot, where it just knows so much and is able just as a base model, able to answer so many questions with high quality. And so the next thing that we did was we were like, great, well, there's an API for this, so we can easily just kind of, have plug into it, use it in different places in our application. The next thing that became clear was, okay, well, we have all this private data, like user data, other things that we'd want to use to better make our responses even better. And this is where we kind of end up with uh, this architecture, which is RAG. And so to break it down, RAG is retrieval augmented generation. So generation is LM. Augmented means that we're helping it do better, and retrieval just means that we're retrieving data. So obviously, this makes it look very complicated. To make it simple, here's how you can think of RAG. If a user asks, how should I be investing, or anything really, what RAG does is it retrieves relevant data and then it fits it into your prompt structure. So you give a structure of a prompt, like given the user has these attributes, of a variable and using this content from our blogs as context of another variable, answer this question. So this is where this is really what RAG is. I mean, in the end, LLMs take in text as input and output text. So you grab relevant features, relevant data of the user, and then you feed it into that prompt. So why do we do this? Two reasons really. One is personalization. We can start feeding in attributes that and context that's very specific to the user, so that it can be used for that user. And it also tends to do better because of that. Given that you can, pull information, even that things that aren't user specific, like just things, content information that you have, might allow you to do better. A good example of this would be you can feed in some docs of a library. So the LM might kind of, hallucinate some like function call that doesn't exist. It happens all the time. But if you feed in the docs, it's less likely to. So one question that comes up a lot is, okay, like I get it. So I can fit all my relevant data into a prompt. What's keeping me from just shoving all of my data into a prompt? Because you could argue that why do this whole vector database RAG thing if I have this massive context window? There's a few reasons. One is if you actually do this and you shove everything in, uh, sometimes it has potential, depending on the use case, to actually do significantly worse because it loses focus or it tends to focus on the wrong things. Two is it tends to be very expensive, and three is that it's slow. Especially if you start thinking of like, for every single user, every time they ask a question, I now have to feed in all the information I have about them and all the generic information that I have. You can imagine one that the LLM can get hyper focused on something that doesn't matter. It can be expensive and it can be slow. Okay, so let's do RAG. How does it work? So RAG kind of looks like this. Let's break it down a bit. So step one is we pre-process our data. So we'll have all the data that we have on users, on anything. We will typically with the generic version of RAG, the one I'm going to talk about to start talking about, you start typically with documents, you chunk them. The way you chunk them is kind of it's a hyperparameter, so you can decide however you want to do it. You embed them. So I'll get into what that means in a moment. You put them in the vector database, and that is your pre-processing. So now all of your context is stored somewhere it can be retrieved. So now when the user asks a query, we go into the retrieval step. In the retrieval step, we query the vector database for the closest chunks. We put them into our prompt, and then we feed that to the LLM, like I was talking about earlier. So this is RAG, or this is how we're almost all taught RAG. But we're bringing in all these concepts, right? Like we're bringing in embeddings, vector databases, etc. So let me break those down a bit more so we can really understand what's happening. So firstly, what is an embedding? An embedding is a vector. So it's just like literally like a point in space. And these vectors have a really interesting property about them, which is that things that are considered similar by the model are close together in space. So they kind of cluster. So in this image or in this, image I have here, what this is doing is it's creating embeddings off of uh, images of clothing. And you can see that it actually starts to cluster together things that I consider similar. And so you see like the bottom rights or shorts. You can see that, swimwear ends up here. You can see, and it decides that black clothing or black long clothing is down here. It kind of finds its own way to cluster these things together in a way that makes sense to it. So why is that useful? Well, for two reasons. One is if I need to grab similar items, like, hey, I have this image, I want to find images like it, or I have this piece of text, this query, user query, I want to find text that is similar to it or seems relevant to it. I can do a nearest neighbor lookup. So I can find points or embeddings that are similar to my embedding to find similar content. And this is a huge part of what RAG is. The other use case of embeddings, which is less common in RAG, but I just thought I'd speak to, is the embedding actually works as like a dense representation of things. For example, if I'm using a traditional model, like here on the right, um, it's actually can be quite hard to feed in text directly. Like you can tokenize and do like a ReLU, like what an LLM is, but typically with like what you're going to want to do is have some dense representation of it. And so an embedding works that way. Okay, so we have these magic embeddings that we're able to generate. How's it happen? How do we actually create them? We use something called a transformer, which is not the robot in the middle, but the model on the left. And one of the most famous kind of early versions of the transformer was a model called BERT. Not the yellow guy, but a paper that was written. And it's interesting that like these models are actually quite similar to LLMs. LLMs are decoding models, are decoding only models, and Transformer is an encoding only model. So it is uh, yeah, it is interesting how they kind of are very related and they're used right next to each other. Okay, so now we have embeddings. We realize that, okay, if I do a nearest neighbor lookup, I can find similar items. I have transformers that I can use to build those embeddings. Where's the vector database come in? Well, that nearest neighbor lookup I talked about, if you do it naively, it's actually very expensive. It's impossible to do perfect nearest neighbor lookup. It's impossible given let's say like 1,000,000 points. If I want to find the 5 points that are closest, um, I have to pretty much do like pairwise checks of everything. It's a very, very expensive operation. So over the years, there have been these algorithms that have been created, which are called approximate nearest neighbor algorithms. The goal of them is to approximate that nearest neighbor lookup. And so, for example, a very common one is one called HNSW, which is actually being shown here. In HNSW, what it does is it kind of almost like puts together close points into single points so that you can start at the high level and just quickly get to like kind of the neighborhood you need to be in, and then you can go down a level, get closer, you go down a level, and then you can really like you have everything and you can find the ones that are close. Now it's approximate, so it's not guaranteed to be perfect, but for many use cases it works really well. And so there are different like there's IVF, which is what Postgres uses. There's many different ones. So that's one difference between vector databases is the index that they use and support. And so what a vector database is it's a database. So it's durable storage of your vectors, but it also indexes them using an approximate nearest neighbor index so that it can do nearest neighbor lookups very quickly. Great. So let's summarize. RAG is the problem where what RAG does is it retrieves the most relevant data to given a prompt to the user and some other metadata. So it makes sense. We need to use our data to personalize and improve AI. So it makes sense then, step two, that, okay, we're going to retrieve relevant context for our prompt. So how do we do that? Well, for some reason, we've decided that the best way possible, given the context window, which is n size, you need to fill it with the most relevant information possible. And so somehow we've decided that if we randomly chunk our documents, embed them and stuff in the vector database, and do a nearest neighbor looked up based on the query, but that's going to get us the most relevant context possible for a prompt. It's kind of a naive take. It's very obviously not going to give you an optimal context window. It's going to do pretty well. It's better than nothing. It's better than a lot of other methodologies that we have, but it's obviously not optimal. Like if you think about it logically, like there's just no way that those random chunks are going to be the most relevant information that we have across all of our data if all we're doing is a vector database lookup, a nearest neighbor lookup on the question. There's a lot of methodologies that have come from this. For example, what some people will do is they will ask the LLM to answer the question with this zero shot, and they'll actually embed the answer. So there's a lot of tricks that people have to try to do better. But this is like a big problem of RAG, is that it's not always getting really great context. So, but why do we do it this way? One is that every tutorial teaches this as RAG. So if you look up how to do RAG, you're going to get the exact same implementation that I showed you. You're going to chunk data, create embeddings, put them in the vector DB. The vector database companies have built a ton of content around this, which is great. And they also benefit from this specific implementation because the vector database is a key component of it. And finally, it actually works pretty well. It's a great benchmark. Like if I was building a more complex RAG system, I would first build this one, have a benchmark, and then see if I can improve how much I can improve on that benchmark. The final bit, which isn't on the slide, but is also that even though it seems complicated, it's actually quite relatively simple compared to some of the other things we're going to talk about. So the other big benefit is just the simplicity of the method. But let's see how we can do better. So Microsoft released a paper called GraphRag. A lot of people think of GraphRag as a very different kind of concept in the sense that uh, it just has rag in the name. But actually, it's very similar in what it's trying to do. It just does it very differently. There's two steps. The first step is the pre-processing step. So in the pre-processing step in RAG, as you may remember, what you're doing is you're chunking your text and you are turning it and then you are embedding those chunks. So that's kind of your context. GraphRag takes a step further. It asks the question of instead of just using embeddings on chunks, couldn't we do better if we actually took our text and had the LLM try to get denser information about it, maybe in like a graph form. So you can actually start to like really lay out everything that happened. So for example, here you can kind of see it's rather than just having, random chunks of text from whatever this is coming from, you can actually see that it's a pretty dense and clean representation of what's happening here. And then there's the retrieval step. So the retrieval step of GraphRag, in the actual paper, they talk about it, but there's different ways they talk about it. But generally, you could imagine one is that you could actually generate queries that will query this graph so that you can grab the most relevant pieces of information from the graph. The other thing that we could see or we've seen is that you'll cluster this graph and then you'll summarize the clusters so you can start to really figure out how these things work together. This has some benefits. One is that you're spending more time pre-processing. So the context that you get is going to be way denser rather than just having like kind of just like random paragraphs. Think of taking any paragraph from a blog post. Like 90% of the words are just fluff. There's really only like a few sentences in each of those paragraphs that are really, really dense context. So GraphRag tries to distill into that more dense representation of the information. And for retrieval, it gives you a lot more options on how you can do retrieval from working at the global level where you're summarizing the graph, working at the local level where you're just querying based on like some user. So, and then finally, it also has the ability to go across text. For example, if something happens to someone in the first paragraph and then something happens to someone in towards the end, if you do typical RAG, unless you get both those chunks or get all the chunks that are relevant to those pieces of information, you might miss some stuff. Where here, it's very dense. So all the really relevant information is right next to each other. Now, GraphRag is very interesting. And I think it's really interesting from a not just like the actual implementation perspective, but if you start to generalize it, you start to realize that, okay, like there's a lot of ways we can do better than just let's just, embed random chunks. There are tricks like even without using graphs, like summarization, there are just a lot of pre-processing steps that can be done that might enhance the context you get for RAG. Now, the problem with GraphRag is, it has a lot of complexity that comes with it. It's not really clear what the best way to do it is, and it's going to really depend on your use case. So there's just a lot more complexity to even implementing this. Unlike in, RAG, where it's a very simple implementation, here there's so many things we can tune. And then the graph database companies, similar to the vector database companies, have kind of really jumped on this because it kind of gives them a really powerful use case. The problem there is it adds a lot of noise to the category, to the space, because it's kind of hard to tell what's real and what is, kind of companies pushing their own product. But I mean, it's still, like I said, it's quite complicated. And I think, getting back to basics, if a user asks, how should I increase my credit score? We could do naive RAG. If we do naive RAG, we might get lots of paragraphs from our content base about how to increase credit score. We could do graph RAG, and we can figure out, okay, a credit score is associated with these, 19 things. And so that might give us a good representation. But wouldn't it make sense when answering that question to just to have the user's credit score, their spending history, their current debt, etc.? And isn't it clear that a user's credit score is not going to live in a vector database or a graph database? It's probably going to live in like Oracle or Postgres or some like old traditional database. But we could totally see that if we just grabbed those pieces of context, they may be significantly more valuable, especially per token, than paragraphs from our blog post when answering this specific question for this user. So part of what I'm really getting at with this talk isn't so much, okay, like we should use GraphRag and not use vector databases. I actually don't think that's true. I actually think that that's not what you should do very clearly. Like you should use the right tool for the job. But just what I think we need to get back to thinking about this less from an input, like a solutions perspective of like, oh, GraphRag, use that everywhere, or vector DBs, just like throw naive RAG on everything. Really, the first principle is let's get the most relevant context. And you can use GraphRag, vector databases, etc., to build the most rich data possible for that piece of information. So you can use all these different indexes to build the most kind of data-rich representations of all the information you have. And then at prompt time, you can choose which one of these things is going to be most valuable for you. So imagine now that, okay, I have all these attributes. I have, nearest neighbor lookups. I have these different graphs that are built in different ways. I have all these attributes of a user. I have all this context and really things that I can pull, different databases I can hit. And then I can decide at prompt time which information is most relevant. But that problem is hard too, right? How can I decide what's the most relevant information possible? With a vector database lookup, I'm allowing the embedding nearest neighbor to be my decision making. For GraphRag, I'm using the graph to make my decision making. But if I go a step up and I kind of start to mix all these things together, it becomes a little less obvious which one to use. I can hit all of them, but then I'm just stuffing a ton of information into my prompt that may be repetitive and may not be useful. So the trick that we've seen to try to solve this is mixing in an agentic workflow for retrieval. So if I have, let's say, like a catalog of all these different like pieces of context I can query, we can ask the LLM to decide which of these things from is actually relevant. So if I have, hey, the user asks how to increase credit score, and I know their favorite song, the LLM is going to be like, yeah, that's not useful. But if I have, their spending history, that's going to be useful. So you can use an LLM to actually be the filter to decide which things are relevant for it to solve its own problem. In an interesting way, RAG kind of becomes a tool that that an LLM can use. So when we do RAG naively, you can think of it that we have a tool, which is the vector database lookup, but we force the LLM to use it each time. A really simple way to make it agentic is just ask LLM if it is worth doing a nearest neighbor lookup. If you go a step further, you can tell the LLM, hey, I have these 15 databases I can hit, these 15 different attributes I can get. Which one of them are useful to you? And so we call this concept feature RAG, where you have this catalog of all your contexts, like for all the vector database tables you have that have your index content, all the graphs you've created, all the attributes you have on users maybe it's just things like, again, like their credit score or whatever else. And we use an agentic workflow on top so that you can actually ask the LM, here's a catalog, which things do you want to be able to answer this question? And we're still in the early days of this, but we've seen some really interesting examples of this working really, really well. And we actually think this is where RAG's going to go. RAG is going to go from being this thing that we just kind of hard code a vector database lookup into. And it's not going to go into let's hard code another type of index like a graph, like graph RAG, but rather let's make this thing a little more generic and allow the LLM itself, the agent itself, to figure out what data it needs to solve the task at hand. So it all starts with data. I mean, that's always been like our view at Feature Form is let's build better signals out of our raw data for all of our use cases, whether it's LLMs, traditional models, or basic analytics. It really all starts with data. And by using agentically, we can really start, we're pretty much telling the LLM, hey, I have all this data, I have all these attributes I've built, I have all these analytics, all these tables. You have free reign on it to grab what you need that is relevant for you to solve the problem at hand so you can do the best job possible for our end users. So that's all I have for today. I know that's a lot of information, but I'll open up for questions. If there are any questions, you can throw them in chat. If you're on, or sorry, in the Q&A section, if you're in the Zoom. If you're on LinkedIn or anywhere else that we're streaming, you can just ask in the comments, and we'll also be looking there. So I'll give it a few minutes to see if there's any questions. And yeah, so one of thanks, much appreciated. I'm glad this was useful. And then there's kind of a question of like, hey, how can we keep up with all this? So two ways. One is connect with me on LinkedIn, follow me on LinkedIn, whatever. I will be posting and continue to post a lot about these kinds of things. The other thing is if you find the Feature Form company page, you can follow there, and we'll be putting a lot more content and follow up webinars there. Um, Yeah, so there's a question of like, okay, RAG is used. So we are using RAG to make the prompt more informative of relevant context. That's true. So that is what RAG is. Like RAG at its core is I am trying to inject relevant information into a context window. And then that context, I mean, LLMs read text. So I need to take that context that I created and fit it into a prompt structure. And then that gets fed into the LLM. And so in practice, if you do this well, you will end up with better results. What about, so there's a question of cost with graph rag and naive rag. So graph rag is significantly more expensive than naive rag, significantly. Because if you do it the way that that the paper talks about, you have to take, you pretty much are doing kind of that same sort of chunking that you do in naive rag, but rather than running a transformer on each of them, where transformers are typically much more lightweight, you actually are running an LLM operation on every single chunk. And if you do it the way that the paper talks about, you then actually do it again. So you kind of end up like reprocessing things over and over again. So GraphRag specifically is very slow and expensive. And it can do better depending on your use case. So there is kind of a challenge there. That's why, again, we're not necessarily saying graph rag is the answer, but we're saying if you think beyond just like there's two options, there's naive rag and graph rag, what attributes do I have and how can I choose them? If you start moving to that direction, you can really start to move past just the basics. So someone asked for a use case where feature rag will be more useful. A lot of the use cases I think about have to do. So let me give you a few examples. One, let's talk about e-commerce. Okay, almost like a recommendation system. So I'm talking to a user, or not even a recommendation system. Let's say that you are a help bot for a user, and a user asks, "Hey, like my last order was broken." Well, you'd probably want to know what their last order was, right? And that last order, again, is not in the vector database. It's not in the graph database. The last order is probably in like DynamoDB or something. So this is an example where you could tell the LLM, hey, I have these attributes of the user. One of the attributes I have is the last item they bought or the last 5 items they bought. Is that something you'd want? So you can, that's how it works. You're kind of giving it almost like memory. Like, here's all the attributes I have. Which ones do you want? So an example would just be anything where you need to do like a key value lookup. So there's many, many, many examples. I gave one. The other one I gave was a credit score one. In all those situations, you're going to want something like feature rag. Because unlike the vector database stuff, you kind of need to choose which attributes, and that's where you really want to do the feature rag piece of it. So when saying nearest neighbor lookup, are you referring to cosine similarity or MOR under the hood? It doesn't really matter how you do. Well, it matters. So the question is like, how do you do near like what's the actual implementation of nearest neighbor lookup that you do? So typically, like the generic way that I typically learn it is by cosine similarity, which is just like it has to do with the angle between them. Some people do like Euclidean, which is like literally doing distance. That doesn't typically work as well as cosine because it doesn't scale well to like 1,000 dimensions. So there are many different ways to define how two points are similar, and that's just a hyperparameter. So that's kind of depends on the use case. But cosine similarity is a pretty generic one that people tend to start with. Okay, so any framework that makes it more automatic. If I have one user to upload 10 documents, how do I choose the most relevant? For instance, I have 10. So, okay, I'm going to read this first, and then I will explain what it's saying. Yeah, so there's okay, so that's really interesting. So someone says, okay, a user asked me um for let's say like a company's income, like how much money did Apple make in a quarter, but then they don't specify the quarter. Um, how should the system reply? So this is where again you can get really creative. Some people what they'll do is they will in their prompts actually say, "Hey, if you are unsure, you need to ask a follow-up question. Just ask your follow-up question." So one way to do this is actually create your prompt in your agent in such a way where it will actually ask for more information if needed. So that's definitely one option. The other option is if you do it generically and you don't give it that option, it's just going to do its best, which is, and that's where you can really run into like hallucination problems. Another example of this is if someone asked for the income 15 years ago or something, and you don't have that data, but you have 16 and 14 years ago, the LM might just decide to guess what it was 15 years ago, and that can be a big problem. So it's a really good question. There isn't really any framework to make this more automatic. And I think that's a good thing to an extent. Some of the stuff can be made and automated, but I actually think that it gives the user openness to be able to tweak and make the system work as they'd expect it to work. Now, obviously, that can, add a lot of complexity. Um, and I think what's going to happen is like as more people give talks and more information comes out, we'll start to really nail down some common workflows and that will make things easier. That's a really good question. Thank you. Um, how can we effectively address and mitigate hallucinations when handling temporal data, such as querying against corollary reports in RAG system? Yeah, so there's a few ways to do that. So one is more simple, which is just that you can in the prompt say things like if you're not sure, say you don't know. That's a really common, really boring way to do it, but it works actually. It can work well depending on your use case. The other way you can do it is even before you get to lots of the answers of like how to mitigate hallucinations is really two parts. One part is make sure it has all the information that it needs, and then two, make sure to give it the option to not answer the question. The problem with LLMs, one of many, is that we're very eager to answer questions. So it wants to answer. And it doesn't let the fact that it doesn't know keep it from trying to answer the question. And that makes it even worse when it yeah, it can make it even worse when it is also very good at sounding correct. So even when it's hallucinating, it's actually not always very obvious that it's hallucinating. A good example of this is like I was working with a junior engineer on our team who was asking a question. She was trying to get something to work and she couldn't get it to work. And ChatGPT was actually giving her a function that seemed like it should exist, like it's just a method in the library. It seemed like it should exist, but it actually didn't exist. So it does stuff like that. So I think in practice, if I had the one trick to have solved that was give it the actual docs. If you gave it the docs, it would have been able to probably figure that out. And then two, tell it if you don't know, just say you don't know. How do you handle data quality with raw data? And how do you make sure that the signals generated are accurate and reliable, especially for complex models like LLMs? Good question. This actually goes back to like kind of the basics of like data and data science and ML. I think we always get really caught up that LLMs are very different. And in many ways they are. But especially when we're talking about like context windows and input data, like lots of the questions of data quality and noise are the same exact problems that like a data scientist deals with a more traditional model. So how do you make sure that signals are generated accurately and reliable? Well, you can use like I mean this is one thing feature form solves. I don't want to like make this a sales pitch, but like this is one of the things that we specifically do is we make it possible for you to define your attributes as code. And so then you're guaranteed that it will be reproducible, it's versioned, it's accurate, it's documented, etc. Now, the next question, or just kind of another part of this question that's really, I think, interesting, which is like, well, the models are complex. And that's true. And what that creates is like this really tough abstraction, which in some ways is really good because like if you give it imperfect data, it will try to kind of smooth that out itself. But the problem is when it does things wrong, it's really hard to like debug that and make it do things right. So that's this kind of a problem that will continue to exist with LLMs. The way to solve that is to build better guardrails, build good monitoring to make sure you know when it does things wrong. And when it does something wrong, look at what happened and why you think it did that. But I think this is something we're going to deal with a lot in LLMs. It's also very true of embeddings as well. Um, for embeddings, like when embeddings cluster wrong, you can end up with really weird things happen. And the problem is that it's not really easy to fix. You can try fine-tuning the embedding model, but even that problem might not fix it. So this is just going to be kind of we're working with like no longer working like black and white, where hey, this function always has this response given these inputs. We have these fuzzy functions, which are like LLMs, and it's just going to create a lot more focus, a lot more imperfect systems, a lot more focus on trying to kind of make things better and less make things perfect. Right. Any challenges, limitations, drags that we still need to address more? I think the biggest problem is kind of like to what I spoke with here is that we're treating the naive rag kind of like hammered. When you have a hammer, everything looks like a nail. So I think that's one big thing I'm trying to change. I just want people to get back to the first principles. In terms of RAG itself, I mean the goal of RAG is very simple. If you think of it in first principles, like you have a context window, you want to fill it with the most dense, relevant information possible for the LLM. How do you do that? And that's the open question. And I think that there's way more room to be creative than I think we're giving ourselves room and credit for. So the question is RAG kind of a prompt strategy? Uh, kind of like I think anything that works with LLMs is kind of a prompt strategy to an extent, except for things that have to do with fine tuning. Because really, there's only two things you can do to a model, right? You can uh, change what you feed it as input, or you can fine tune it, which will make it behave slightly differently. Those are really your two options. You can do both too. A lot more focus has been towards the data input side, which is how do we, change our prompt to do better? One way to change your prompt to do better is just write your prompt slightly differently, so that you get a response that's better. For example, whenever I am using ChatGPT, I almost always ask it to keep things short because it tends to want to give me too much information. I just sometimes just want a paragraph. So that's a prompt strategy. Now, RAG is also changing the prompt. So we're also tweaking the prompt. But the difference with RAG is that we are using retrieval to augment the prompt. So we are retrieving relevant information and feeding it into the prompt. That's really what makes RAG RAG. A lot of questions today. It's cool. Awesome. Well, I'll give it one more minute if there's any last minute questions. Otherwise, this was a lot of fun. There's a lot of really good questions. A lot of really good questions, actually. So maybe Marie, I can hand it off to you to do the sign off and how people can follow along.
Sure. Thanks everyone for watching our webinar. Just so you know, after this, I'll send you guys a recording of the webinar. I'll also send you guys links to the Slack community, LinkedIn, ways you can connect with us. I know I responded to the individual's question about how can you follow us on LinkedIn, so you can see that answer there, but I'll also send it in a follow-up email. And please also, if you have any feedback or would love to see us do another webinar of something specific that you'd like to know more about, let us know.
Awesome. Thank you, everyone.